Alrighty, folks, welcome back to Time for Change, where we're going to look at the difference between physical and chemical changes. So, to get started, physical changes involve changing the shape, size, temperature, or the physical state of something. So, a phase change would be something where we have a physical change in the visible structure without changing the molecular structure. This is when we change generally the state in which the matter is. So, if we take our Baja freeze, which is currently in a frozen state, we leave it in a car overnight, it's probably going to melt, assuming it's the middle of summer, and that's going to change from a solid to a liquid state. Okay. Then if we were to have a glass of water and we were to boil it, that water would be released in the form of gas. Okay, so these are different phase changes, and we'll do some stuff with phase changes in class when we make our Baja freezes. Phase changes may or may not be reversible. That's important to note as well. So physical changes may or may not be reversible. So sometimes when we physically change something, we may not be able to bring it back. So for example, chopping wood. If we were to chop a piece of wood, it's going to be pretty hard for us to put that wood back together and make it be the exact same. Okay. Chemical changes, on the other hand, are when new substances with different chemical and physical properties are formed. This produces a change in color, odor, or flavor, or release of a gas. Chemical formulas can represent the compounds in a physical change. When we have a chemical formula, the reactants are going to be on the left. There's going to be an arrow connecting everything. That's going to symbolize the change or the reaction that's occurring, and what's yielding, and the products are what is yielded from the chemical reaction. Those are located on the right. Chemical changes may or may not be reversible once again. Okay. We talked about this earlier as well, but the law of conservation of matter, or law of conservation of mass, states that matter can be changed but not created or destroyed in a chemical reaction. So our chemical formulas or equations must balance by having the same number of each type of atom on both sides of the equation. So if we take a look at our equation over on the right-hand side, we see that we're adding methane and oxygen to yield carbon dioxide and water. Now, if you wanted to hit pause and confirm that this is the correct chemical formula, you most certainly can, but I'm telling you that there are four atoms of hydrogen on the left side, which again, those are the reactants, and over on the right-hand side, those are our products. There are 4 hydrogens. There are also 4 hydrogens over here because there are two of the superscript of water. So 2 times H2, 2 times 2 is 4. So that means there's going to be 4 atoms of water on this side as well. So it balances. The whole equation balances. The matter is not created nor destroyed in this chemical reaction. We are going to stop there. It's important to know from this section that there are 2 types of changes, physical and chemical, and that matter cannot be created nor destroyed in our chemical reactions. Tune in next time to learn a little bit more about how energy is transferred. Thank you very much. Have a great rest of your day.